Okay, good morning to all. So, today we will start our next topic, that is the regular false method. So, this is also the method for finding roots for the non-linear equation. Please wait. Okay, you all can see my screen.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
Okay, so uh, should I repeat this because connection was lost?
Yes,
So
sir.
Yes, sir.
this
Yes,
is
sir.
Can repeat it.
a polynomial. You can see that. Okay, this is f. Okay. This is fx is equal to 0. This is a polynomial. So we want to determine the root, one of the root of this polynomial. So how do we do is that we take the value of function at x is equal to x naught, which is f of x naught, and take the value of function at x is equal to x1, that is f of x1. So we have two values. So if you carefully look at these point f of x1 and f of x2, so if you multiply these f of x0 and f of x1, then we will get a negative value. That means root is must be lying between somewhere between interval x0 and x1. So now we can approximate this polynomial by a straight line, or you can say a chord C joining between point A to B. So we have drawn a straight line joining between point A to B. So now you can see this straight line cuts this x-axis at point x2. So once it cut at the point x2, so this x2 is one of the approximate root of this function. So we can write the equation of a straight line joining these points, and if you substitute y is equal to 0 in this equation of a straight line, you we can get the value of x2 in terms of the known parameters, that is x0, x1, f of x1 and f of x0. We can get the value in terms of known parameters. So you can see here that we have expressed x2 in terms of the known parameters. So this method consists of replacing the curve AB. There was a curve AB. We have replaced that curve AB by means of a straight line, or in particular, you can say by means of a chord connecting, joining two points, that is point A and B. So now if f of x0 and f of x1 are of opposite side, the root lie between x0 and x2. So the place x1 by x2 in one, we obtain next approximate x3. So we will be doing this exercise regularly until we get the desired accuracy. What this exercise is, that we have joined the point A and B within a straight line. Then we have written an equation of a straight line passing between point A and B. Now it is clear from the figure that that this straight line cuts x-axis at some point x2. Now we take x2. Now we take this x2 as one of the root, and substitute in equation for the state in the equation of a straight line. We substitute y is equal to 0 and get express x2 in terms of x1, x0, f of x1 and f of x0. So this is how we have calculated one of the root as x2. Similarly, once we get the value, one of the root as x2, our next attempt will be again to cut short this interval and get the value of one of the root as x3. Now we will proceed in a similar manner and get the value of x3. Once we get the value of x3, we will repeat this exercise until we get the sufficient accuracy. Okay, so let us quickly proceed towards one of the solved example. We'll see how this is done. So this find the real root of equation x cube minus 2x minus 5 by method of false positioning, correct up to 3 decimal places. So up to third 3 decimal places, we are interested in determining the root of this cubic equation up to 3 decimal places. So we have taken two. You can obviously draw on this graph. and you can approximate it. But you see that at f is equal to 2 we have a value as negative, and at f is equal to 3 we have a positive value of function. So it is clear that this f of 2 into f of 3 will be a negative value. It is clear that root will be lying between interval 2 and 3. One of the root will be lying between interval 2 and 3. So we will simply substitute the formula for the straight line and get the value of x2. X2, once you get the value of x2, which comes out to be 2.0588. Now our next objective is that we will find f of x2, and which comes out to be a negative value again, and we calculate f of x3. We know that f of 3 is nothing but it is 16, which is a positive value. So we are sure that root will be lying between 2.0588 and 3. Next, we will use again equation of a straight line and connecting 2 points. From there, we will get value of one of the root as x3. So we will continue this exercise until a desired accuracy is given. In your case, this will be specifically mentioned in the question that do iteration up to 5 times or up to 7 times, 8 times. So whatever be the case, in this case, iteration was done up to x8, and we got the value of one of the root as 2.094 and up to 3 decimal places. Okay, so immediately we will jump on to one more examples. So you please solve it on your own. Give the value.
Sir, which has more
uh,
accuracy, bisection method or this regular false method?
which has more accuracy, bisection or the this regular false method. So
Yes, sir.
you suggest me.
The regular false looks more complex, like, so I think that.
No, you are approximating with this is a straight line. No, you are
Yes, sir.
approximating it straight line, and there you take an average value, straight away average value. Okay, so regular false is means converging fast. Means this is point of convergence. Okay, hello.
Yes, sir.
I will come on to convergence. First, you solve this. You please solve this question. Once we'll deal with convergence, we'll also come on to that part also. But this is not a aspect of this. So you first this. So anyone got this? So someone of you got this question, answer for this question? We were talking about advanced things like convergence and all those things, and you are not able to give the answer of this part even. Rajvardhan.
Yes, sir.
Why don't you give the answer for this? We were asking for the convergence. You first solve the elementary things, no? Straight away, you're trying to
It
jump
is
into
coming approx
complicated things. First, you give the answer for this
0.517 approx.
simpler. So up to what iteration you have done it?
Sir, up to 2 or 3, sir. 3, yes.
3. So what is this x2 value you are getting for this?
x2, wait a minute, sir. Wait a minute. Sir, I am rechecking, sir. मतलब स्पीड में था कर लिए तो 1 मिनट, sir.
Yeah. ठीक. Hello. You can post your answer in this chat box itself.
Okay, sir. Okay.
Okay, so this is the solution for this. So let us discuss this. At x is equal to 0 and 1, we know the value of function are corresponding to 0 and 1 are this 1, and this comes out to be at x is equal to 1. This is minus 2.17798. So once you get the value of a function at fx0 and fx1, we get the calculate the value of f of x2, which comes out to be 0.31467. So now we calculate the value at x2, which is again a positive value. So what we are sure that root is lying between this point 31467 and 1. So next our task is to cut short this interval of 0.31467 and the 1. Then again we use the method of this equation for the straight line and get the value of x3 as 0.44673. Now you get the value of a function at 0.4673 as 0.20356, and we get the value of root as x4 0.49402. In similar manner, you if you will proceed, then you will get x at 10 is equal to 0.51775. So in exams you won't be asked up to go up to 10 iterations, you simply have to calculate up to say 4 or 3. So let us see who can give the value one. X of 4. We have one equation real. Find the this uh, uh, find the real root of equation x log x, obviously base 10, and is equal to 1.2 by regular false method up to 4 decimal places. So one of the hint is that root is lying between 2 and 3. If you are good in plotting this curve, then obviously you will get to know one of the root. You will have one idea of one of the root. So any one of you can give this value of x at 4. You can write it in the chat box. You can say it orally also. Okay, Raj Kataria has given 2.7408. Okay. Okay, 2.7406. So simply you have to this use the equation of straight line and give the answer. Abhijit has also given. Raju has given. Shivam has given. Okay, that's very good. More answers from you people. Okay, so many of you are giving this answer 2.7007 up to this fourth decimal place. Let us see this solution for this. So yeah, so x this up to fourth decimal place and up to going this up to fifth iteration, we get the value as value of this one of the root as 2.7406. Yeah, this is correct. So we have already solved this problem, and this is correct. Most of you have given this correct answer. So let us see solution for this part. Use the method of false position to find the fourth root of this 32 correct to 3 decimal places. Any one of you can give the answer. Suppose that we are interested in this x of 4. So root is lying between, one of the root is lying between this x at between interval 2 and 3. So now we will again use the equation of straight line. Any one of you got the answer? Okay, so we'll look for the solution of this problem too. This if you take this uh, x naught as 2 and x1 as 3, we have seen that this comes out to be a negative value, and well, that means it is clear that one of the root will be lying between interval 2 and 3. So if we perform the this iteration as per the regular false method, and we get x2 as 2.2462. This is we calculate the value of again value of function at x f of x2, and get the see that it is comes out to a negative value. That means we are sure that one of the root will be lying between this 2.2462 and 3. Now again we use this regular false method and take x naught as this 2.2462 and x1 as 3. We get the one of the root x3 as 2.335. So once we get this one of the root as 2.335, and one of the root is also that is it is root is lying between interval 2.335 and 3, then we again perform this exercise, and if we go up to this sixth iteration, that is x of 6, we observe that this comes out to be 2.3779. So this approximate root up to this, if it is asked for, has been asked for 3 decimal places, then we will uh, write this value as taking round of this 2.378. So has anyone given the answer for this question? 2 point okay, 4. Okay, anyways, you have tried it, that's good. So can you solve this problem? This is this sin x e raised to power, or you may say exp exponential, using false position method. So I have drawn a graph for you. So suppose that we are interested in finding the root between 0 and 0.5. Can you give the exact value of that root? So we are not interested in this second root. We are interested in finding the root which is lying between 0 to 0.5. Can any one of you give this answer? So let us see who can give the answer within 5 minutes. We'll wait for 5 minutes. Okay, for Abhijit has given answer. Raj Kritya has given. Vaibhav has given. Ankit has given. Krishnam, Kriti, and Shivam. All are getting this 0.36. Okay, so whenever it is asked, you try to give it in 4 decimal places. Okay, so this is yeah. Okay. Anyways, many of you have given the answer. Let us see what is the correct answer. Point 3604 is the answer as per your calculation. Let us see. So this is this is 0.36 number of iteration. If we go to number of iteration up to 3, it comes out to be 0.36, and more precisely that you gave the answer is correct. That is 0.3604 is the one of the root line between the function between 0 and 0.5. So in a similar manner, you can also calculate the root one of the root line between this 1.5 and 2. So let us proceed towards our next example. So can you find the, if you have done this, you can quickly give the answer for this question even. So, so exponential minus the 3 x square. So give the root between this 0 and 1.5. What is the root between you are getting between 3 and this 3.25 and 5? 3.25 and 5. Any one of you have calculated the one of the root line between 3.25 and 5? Okay, Shekhar Suman has given first answer. Anyone else? Okay, Neith has also given. Okay, once we will calculate one of more methods, secant method, then we will compare this convergence rate also. That means see which is going to converge more faster. And your syllabus is available on your this institute website. You will simply search in the Google this. So you can look in the syllabus section of the institute website. You will get your syllabus for your this numerical method and computational technique. It is over there. I will provide you all the books. You need not to purchase any book. Okay, that's good. Abjeet has given, Motar has given, Dhuru has given, Ayush has also given, Jyoti has given answer. So let us see, many of you have given the answer. Let us see what is the correct answer for this. So correct answer is 3.733. Okay. So you work on this problem if you are not able to solve here. So this is 3.733 and this is up to the sixth iteration. Once we have moved up to sixth iteration, many of you have in fact given it the correct answer. So with this, we will stop here. I'll also give you one assignment based on this. Once we complete, we are close to completion of this unit. And next class, we will start our this Newton-Raphson method. So there we will also solve some of this problem. Hope some of the many of this already answering more people to answer this question, and expect more answers from you people. Okay, with this we'll stop here. Uh, okay, class is over. If you have some query, you may stay here. Or otherwise, if you do not have query, you may please leave. I'll wait for 5 minutes, then I'll end this class. Next class, we will cover this Newton-Raphson method.
हेलो सर।
प्रियांशु वेट करो 5 मिनट, प्लीज वेट फॉर 5 मिनट्स। हाँ प्रियांशु प्लीज टेल।
Sir, I am asking you should give more time to solve the question.
अब बाकी लोग तो तुम्हारा
I mean,
नो नो मीन्स ये इन क्लास इटसेल्फ।
yes, sir. I am
सी
trying in hub
और
and everyone gives answer. I don't know how they are finding answer
okay
so fast.
okay Priyanshu, then I'll give 7 to 8 minutes for each question, but not more than this. Already
Okay, sir, no problem.
yeah, you have people have already solved more advanced problem than these simple problems. Okay, this is it should not take more than 5 minutes for you particularly you people.
Yes, sir. Thank you, sir.
Anyone else? Okay, so if you
So,
do not, please tell who is this?
Sanjeev,
Okay, wait. Please tell.
सर बुक्स कौन सा बुक्स है
So
तो
I will
कौन सा
give you.
लेना
I will give you. You do not have to worry. Everything you do not need to purchase anything. Nothing. I will give you. Wait for some time. I will give you everything.
ओके सर
Like in the strength of material, this advanced mechanics of mechanics of solid course. I gave you provided you everything. In this course, I will provide you everything. So
ओके सर थैंक
I'll end this class. We'll meet in next class.